So far, you've found the greatest common divisor and represented it as the linear combinations, and now we're going to extend that to find all the solutions possible, or very special ones. So find all the solutions of the equation where the greatest common divisor between 48 and 20 is equivalent to 48x plus 20y. And the first thing we're going to do is find the greatest common divisor. So 48 is 2 lots of 20 plus 8, bring the 20 and the 8 diagonally down. 2 8s are 16, plus 4 is 20, bring the 8 and the 4, and you know as soon as you get a 0, you stop. So the greatest common divisor is above the 0, which is 4. So that you know how to do that. Then what do we do to find the linear combination? We start at the one above the 0, we start with the greatest common divisor, and we know that we're setting the 40x plus 20y now equal to 4. So we need to represent it as 4. So 4 can be represented as 20. Take 2 lots of 8. Remember to tick it as you go so you remember which ones you've dealt with. And now we've dealt with that line, we go up a line, and then 8 can be represented as 48, take 2 lots of 20. Let's open it up. So 20 take 2 lots of 48, minus 2 times minus 2 is plus 4 lots of 20. So 4 lots of 20 plus 20 is 5 lots of 20. What were we asked to do? We were asked to express 48x plus 20y, and it equals 4 in this format. So if you know that the greatest common divisor equals 4, you can say that your equation equals 4, and we also have this equal to 4. So if I write this underneath, you can instantly see we now know what x is worth, and we know what y is worth. And that's it. So that is the specific solution for this condition. But if it says find all the solutions, it means there's a general solution instead. So this is the specific one. But what if we were asked for any values for all solutions? We're going to rearrange both of these. So you'll see this one says 48x plus 20 equals 4, and this equals 4. Well, if 4 equals 4, you can set them equal to each other. And this is the step. What we're going to do is bring the 48s together, so we get x's with something together, and we get the y's all together on the other side. When I say that, there is no x's to collect, but we get the 48s together, so we can represent the x in terms of 48. Pull out the common factor, and you get x plus 2. Pull out the common factor of 20, and you get 5 take y. Now here's where your greatest common divisor comes in. You know your greatest common divisor is 4. What that means is you could divide your answers by 4. So that reduces it down as much as it can, because it was the greatest common divisor. You can't reduce it any more than that. So as you've divided through by the greatest common divisor, the equation is reduced as much as it can be, and this means that x plus 2 has to be a multiple of 5, because if there's a 5 multiple of 5 on that side, and these are reduced down, this has to be a multiple of 5. And equally, if this is 12 times something, then the 5 must be multiplied by 12 to balance it out. So what we're going to do is call the x plus 2 equal to 5m, because it's a multiple of 5 and we don't know what the value is, and the 5 take y is a multiple of 2. There's no common factors, it's reduced as much as it can. So what we're going to do is say let x plus 2 equal 5m, so then you can represent x as 5m take 2. And then if we have 5 take y is worth 12m, then minus y would be 12m take 5, or we could rearrange it whatever way so that you can say that y equals 5 take 12m. So if we've got 12 equals x plus 2 equals 5 times 5 take y, then you've got 12 times 5 times something, and 5 times 12, it balances out. What's next? We go back to our equation. 48x plus 20y equals 4. And if 48x plus 20y equals 4, we can now say that the general solution is 48 equals 5m take 2, because that's what's in place of x for any value of m. And 20 is 5 take 12m is in place of the y instead of 20y. So that you have any integer can be put in there and it should satisfy it. Okay. The Diophantine equations sound really, really difficult, but actually it's not that bad. It just means that you could maybe have a multiple. So if we go through a linear combination of two integers equals to the greatest common divisor is a special example of the simplest type. So when you go through it, you find your x and your y. A Diophantine equation is an equation with integer coefficients and one or more unknowns, which is to be solved in the integers. In its simplest form, two unknowns, the linear Diophantine equation would be so many x and so many y equals c, just like you have done. Whereas when you are given one solution, we might be told instead of c, it's worth 2c or 3c or whatever. So the full method of then solving the equation is very similar to that for finding the general solution that you've always done, with one extra step. The whole equation gets multiplied. So I'm going to show you how to do that. Don't worry if you don't get that, I'll show you. So what if I said to you, you were to solve this? Then you would start with 90 and 12. So you'd start with 90 on the left-hand side, and you'd know 7 12s are 84 plus 6 brings 12 down, and instantly you found your greatest common divisor. Your greatest common divisor is 6, because 6 goes into both of them, it's the highest number. You can rearrange it as well. So that means if the greatest common divisor is 6 for 90 and 12, it'd be 90x plus 12y equals 6. And then you would get 6 equals 90 take 7 12s. If you want to see x and y, I'll just rewrite that as 1 lot of 90 takes 7 times 12. So if it was 90x plus 12y equals 6, then x would equal 1 and y would equal minus 7. But with the Diophantine equation, you're not given 90x plus 12y equals 6, it's equals to 18. It's not the same. But if you've managed to find it for 6 and you know that 18 is divisible by 6, then you can actually find a solution, because if you know that 6 is 1 lot of 90 takes 7 lots of 12, then if it's 18, all you do is actually times them by 3. That's it. So then you can say, well, for the condition when it's 18, x is 3 and y is minus 21. So that's one particular solution, because we found one particular solution for when it was 6. You can find it for when it's 18, and all you actually do is solve it the way you always have done, except you multiply to get the solution that you look. Okay. How do you find the general solution of that? So I'll just remind you about general solutions. So if you have equals 18 and equals 18, then you can set the 90x plus 12y equal to 3 lots of 90 minus 21 times 12. Bring the 90s together, bring the 12s. Now be careful here, because the temptation is to pull out minus 12, but it's a plus 12 there, and you have to have it the same as this. So if you pull out 90, you'll have x take 3, and because it's a 12, you need the 12 there, then you'll have minus y minus 21 in the bracket, which is fine. What else do you know? You know the greatest common divisor was 6. So divide both sides by 6. That means that it's 15 times something, and it's equivalent to this. So that means that this is 2 times a multiple of 15, and equally this is 15 times a multiple of 2. So you know about that before as well. So recall you originally said this is for this part here. I forgot to put that there. Don't pull out minus 12. Okay, so that's for the PDF to remind you that it's a 12 there and not a minus 12. Sorry, let's get back to here. So we're going to call x minus 3 2m. So that means x equals 2m plus 3. And for this one here, minus y minus 21 will be 15m, because it will be a multiple of 15. And then that means that you can say y equals minus 21 minus 15m, or minus 15m minus 21. How do you finish it off? You go back up here and say 90x plus 12y equals 18. But we know what we can represent x and y as, and we can substitute in. Okay? So be careful with the sign. The temptation is to pull out the common factor, but you're pulling out the 12. Okay. There is only one question in the whole textbook to do with this. It doesn't come up a lot. All you have to do is know how to find x and y. It's more reliable to do that. But if the actual value isn't the same and it's a multiple of it, all you have to do then is multiply your x and y by that. Okay, so find x and y. For question 50, what I'm asking you to do is find x and y, find any other solutions. So I'm asking you to do more, find a general solution for me as well, because there is only one question. Go to page 263, and in the slide over there's a exam question, but I'll give you more exam questions so you can see they're all the same. Okay, and that's it.